Good morning, good evening, friends. Welcome to my channel, Kitab Se Ek Moti. Today I'm going to talk about a book that had a great influence on me when I was in college, and it's titled An Introduction to Mathematics by A.N. Whitehead. That is Alfred North Whitehead. Now, this book is for a beginner. I mean, it doesn't expect any or presuppose any a deep understanding of mathematics or any understanding for that matter. I mean, if you just know how to count, you can read this book. If you can read letters, and I mean, if you can read basic English, and if you can understand numbers, you can make use of this book. And he covers a vast area. For example, trigonometry and conic and functions, limits, complex numbers, imaginary numbers, and coordinate geometry. So he covers a vast area in just a few pages, maybe 200 or 250 or so, and it's a short book. So I remember I borrowed it from my college library. It was published by the Cambridge University Press, if I'm not mistaken, or maybe Allen and Unwin, I'm not sure. The thing is, if you read this book, you will get a very broad understanding of mathematics, and many of the confusions and doubts that you might have may be cleared if you read this book and ponder over its message. Now, ponder is used transitively in American English. I think you ponder a subject, but intransitively in British English, I think you ponder over a subject. So that's a difference. I would prefer to use it intransitively. So ponder over. You can ponder over the message of this book. So what will it do for you? So it will give you a broad understanding of mathematics. If you have been afraid of mathematics since your school days, this may kind of drive away that fear, and it may kind of infuse some love for mathematics into you. After reading it, you'll know that mathematics is it's not just meaningless manipulation of symbols, but there is a great deal of rationality behind mathematics, and it can help develop our thinking skills, and it can help us understand a subject that has had the most influence on scientific thinking. I mean, if you see, physics involves a lot of mathematics, and modern science, it's used in technology. I mean, how can anyone think of designing these airplanes or these bridges, and how can one think of reaching the moon without understanding mathematics? So mathematics is the language of science. So this will also help you understand the philosophy of mathematics. So I recommend this book. Read it. Also buy this. You need not buy this book. It's available for free on Project Gutenberg. You can just download a copy. A PDF file is available. There is no longer any copyright on this book. Anyone can make use of it. You can just check the conditions that Project Gutenberg has mentioned on its website, and just use it based on those conditions. You can use it for your personal use. I think you can even maybe print it for yourself. I'm not sure. But the thing is, it can be distributed freely and used freely. So now let me come to the passage that I've selected for today. And just one more thing about Alfred North Whitehead. So he was a philosopher and mathematician, and there was a book written by him and Bertrand Russell that had a great influence on logic in the 20th century. So the book is titled Principia Mathematica, or the original Latin pronunciation might be Principia, but I prefer the anglicized pronunciation, so Principia Mathematica. So Alfred North Whitehead, the author of this book that I'm discussing, An Introduction to Mathematics, and Bertrand Russell, one of the greatest philosophers of the 20th century. Both these guys wrote this great book. I think it was published by the Cambridge University's Press, and it was published in 3 volumes. And it was said about this book that hardly 6 or 7 people had read it from cover to cover in the entire world. I mean, that might be an exaggeration, but what I'm trying to say is it involved complex symbolism, and Bertrand Russell and Alfred North Whitehead invented quite a few symbols of their own. So it's a difficult book to read. So now let's check this passage for the day. So I'm going to read it now. We now return to pure mathematics and consider more closely the apparatus of ideas. Now, is it apparatus or apparatus? It's better to check the pronunciation, no harm in that. So I think it's apparatus. Let me check the pronunciation. So yeah, apparatus and apparatus, I think. Maybe apparatus or apparatus, okay?
Apparatus.
Okay, so apparatus and apparatus, both are fine it seems, but the standard pronunciation, the preferred pronunciation is apparatus. Apparatus. Okay, that might be the American way. So we now return to pure mathematics and consider more closely the apparatus of ideas out of which the science is built. Our first concern is with the symbolism of the science, and we start with the simplest and universally known symbols, namely those of arithmetic. Let us assume for the present that we have sufficiently clear ideas about the integral numbers represented in the Arabic notation by 0, 1, 2, 9, 10, 11, 100, 101, and so on. This notation was introduced into Europe through the Arabs, but they apparently obtained it from Hindu sources. The first known work in which it is systematically explained is a work by an Indian mathematician, Bhaskara. But the actual numerals can be traced back to the 7th century of our era and perhaps were originally invented in Tibet. For our present purposes, however, the history of the notation is a detail. The interesting point to notice is the admirable illustration which this numeral system affords of the enormous importance of a good notation. The interesting point to notice is the admirable illustration which this numeral system affords of the enormous importance of a good notation. By relieving the brain, now I'm getting a phone call, so I'm a bit distracted. Let me just read it again. But the actual numerals can be traced back to the 7th century of our era and perhaps were originally invented in Tibet. For our present purposes, however, the history of the notation is a detail. The interesting point to notice is the admirable illustration which this numeral system affords of the enormous importance of a good notation. By relieving the brain of all unnecessary work, a good notation sets it free to concentrate on more advanced problems, and in effect increases the mental power of the race. Before the introduction of the Arabic notation, multiplication was difficult, and the division even of integers called into play the highest mathematical faculties. Probably nothing in the modern world would have more astonished a Greek mathematician than to learn that under the influence of compulsory education, a large proportion of the population of Western Europe could perform the operation of division for the largest numbers. This fact would have seemed to him a sheer impossibility. The consequential extension of the notation to decimal fractions was not accomplished till the 17th century. Our modern power of easy reckoning with decimal fractions is the almost miraculous result of the gradual discovery of a perfect notation. Mathematics is often considered a difficult and mysterious science because of the numerous symbols which it employs. Of course, nothing is more incomprehensible than a symbolism which we do not understand. Also, a symbolism which we only partially understand and are unaccustomed to use is difficult to follow. In exactly the same way, the technical terms of any profession or trade are incomprehensible to those who have never been trained to use them. But this is not because they are difficult in themselves. On the contrary, they have invariably been introduced to make things easy. So in mathematics, granted that we are giving any serious attention to mathematical ideas, the symbolism is invariably an immense simplification. It is not only of practical use, but is of great interest, for it represents an analysis of the ideas of the subject and an almost pictorial representation of their relations to each other. Now, after this, there are given some fundamental laws of algebra. I'm just thinking whether I can skip these, because without a blackboard or without a board, it might be difficult to explain this. So let me just skip a few lines and let me come to the last part of it. Okay. This example shows that by the aid of symbolism, we can make transitions in reasoning almost mechanically by the eye, which otherwise would call into play the higher faculties of the brain. Now, what he's trying to explain is this. For example, there's this x plus y is equal to y plus x. So if you say that in words, it might be like if you add y to x, that's the same as adding x to y, and so on. That takes time, that takes too many words. But symbolism, or proper use of symbols, right? Or simple use of symbols, x plus y is equal to y plus x. I mean, so it's so easy to retain in our minds, and we can do that operation quickly. It is a profoundly erroneous truism repeated by all copybooks and eminent people when they're making speeches that we should cultivate the habit of thinking of what we are doing. I mean, that's what we say, think whenever you do something, just think about it. The precise opposite is the case. Now, this might seem a bit counterintuitive. Civilization advances by extending the number of important operations which we can perform without thinking about them. Operations of thought are like cavalry charges in a battle. They are strictly limited in number. They require fresh horses and must only be made at decisive moments. Now, in the world of AI and where we have this Google Translate and things like that, it's true. I mean, I can make my videos. Now it's a bit windy, so my apologies for any disturbance. I was talking about Google Translate, for example. It quickly translates material from one language to another. But if I use my thinking power for that, then I'm kind of using a great part of my life. I mean, a chunk of time or a segment of time for an activity that can be done quickly by means of some automatic process. So I can use that portion of my life for something more significant. That's the advantage of proper symbolism and operations that quicken the process of our thinking. Or, they just make thinking mechanical. For example, when the calculator came in the market, people started doing all these additions and divisions and subtractions and addition, subtraction, multiplication, division, etc., square root, extracting the square root, and finding out the powers of certain numbers. So what I'm trying to say is that made our jobs extremely easy, or that saved us a lot of time. So instead of doing all those things manually, we started using the calculator for that. So has that helped humanity? I think it has. Has it caused any problems in the thinking process? I don't think so, because the fundamental operations need to be known. So we need to know what we do when we add, what we do when we subtract, and so on. We need to understand the logic behind all these mathematical operations, but then we need not do them manually. That's why technology has been advancing, and we have been getting new tools to do all those things that needed manual effort during the years gone by. And so what Alfred North Whitehead is saying is that your symbolism is important, and that it has to be simple, and that it has to be pictorial, and it needs to make all these thinking operations kind of automatic, so that you need not think while you're doing it. You just see the symbols, you just manipulate the symbols, and you're saving your thought process for something more significant. That's what advances humanity, and that's what will make you a good thinker as well. So that the more processes that you can automate using your simplified symbols, the more you can use your brains for more significant things in your life. So this was the passage that I wanted to discuss for the day. But I recommend this book. You buy this book, read it. You can also buy this for your children. If they are in maybe 9th standard, 10th standard, I think they can understand this. And if you're in college, you can still buy this book and read it, so you have a vast and broad understanding of mathematics, and you have it from one of the most eminent mathematicians of the 20th century and one of the great philosophers of the previous century. And your English will improve. His language is excellent. So you need to read these books. For example, read G.H. Hardy's autobiography. And you may also find this World of Mathematics by James Newman, I think. That's an excellent book. I'm going to make a few videos on that book as well, The World of Mathematics by James Newman. You need not be a mathematician to read these books. Just anyone who can add, subtract, multiply, divide can understand these books. Mathematics is not beyond anyone, because As human beings, we have this inherent in us, this ability to add, the ability to subtract, the ability to multiply, and the ability to divide. So I hope you like this video. I recommend the book again, just to recapitulate. Symbols need to be simple, and mathematics has advanced because of its symbolism mainly. So what it does is it kind of makes all these operations automatic. So it's so easy to focus on the more significant matters, and we are sure that we are right by just looking at the symbols. For example, we know that x plus y is equal to y plus x, so we need not spend more time on doing that operation. We can use the time of our life, significant portion of our life, on matters that are of greater importance for humanity. So with that thought, I would like to conclude this video. Thanks for watching.